Okay, 3.3. 3.3 is looking at proofs with parallel lines. Now, don't let this scare you, okay? We know parallel lines. We're good at this. We're going to be all right. Let's get right into it. We have to write the converse of each conditional statement. Okay, remember, back in chapter 2, we talked about conditional, converse, inverse, and contrapositive statements, and the biconditional. Here we're writing the converse. Okay, what's the converse? Let's start with that. The converse, I'll write over here, is if Q, then P. Okay? Let's look at this first statement. Okay, if we want to write the converse. If two parallel lines are cut by a transversal, so if two parallel lines, there's my P, are cut by a transversal, then the pairs of corresponding angles are congruent. There's my Q. And we want to write if Q, then P. So let's start with writing the converse. We can say if two lines, and we didn't say parallel, we said if two lines are cut by a transversal, if two lines are cut by a transversal, so that the corresponding angles, okay, so that the corresponding angles are congruent, then they are parallel. Then the lines are parallel. Okay. So we needed our Q or our P to be at the end, right? There's our P parallel, and we wanted congruent. Okay, so right there, if two lines are cut by a transversal, so that the corresponding angles are congruent, then the lines are parallel. Okay, let's look at B. B, if two parallel lines, there you go, there's parallel lines, there's my P, parallel. Then they're congruent, okay, there's Q. I'll break this down a little bit for us. If two lines are cut by a transversal, okay, and the alternate interiors are congruent, no, so that, not and, so that the alternate interior angles, I'll write my little angle sign here, are congruent, then those two lines are parallel. Okay, so only if those two lines cut by a transversal, only if the alternate interiors are equivalent, then the two lines are parallel. Okay, if those were not equivalent, then we could not say those two lines are parallel. Moving on to number 3, or C. Parallel lines cut by transversal, right? Same exact thing. Now we're looking at the alternate exteriors angles. So if two lines cut by a transversal, okay, so that the alternate exterior angles are congruent, then the lines are parallel. That would be our converse. Okay, only if those two alternate exterior angles are congruent, then the lines are parallel. That is our converse. Okay, now it's consecutive. Consecutive interior angles. This one's a little different, only because consecutive interior angles are supplementary. They add up to 180. So we can say if two lines are cut by a transversal so that the consecutive interior angles are supplementary, then those two lines are parallel. Okay, there's our converse. And if we have questions about the converse, we can ask in class or an email. Okay, let's move on to number 2. For which of these theorems involving parallel lines and transversal is the converse true? Okay, well, only when those things work out that those lines are parallel. Okay, so actually every one of these, every converse is true. So all of those are true. All converses are true. Okay, when we talk about those congruent angles with corresponding angles, alternate interior, alternate exterior, okay, those are only congruent if the two lines are parallel. So those are true. And then the corresponding angles, or consecutive interior angles, sorry, the consecutive interior angles are only supplementary if those two lines are parallel. Okay, so all of these are true. Number 3, in exploration 1, how would you prove any of the theorems that you found true? Well, let's just look at the first one. First one up here was corresponding angles. Okay, so if you assume the converse, okay, or if you prove the converse, okay, corresponding angles are only congruent when the two lines are parallel. There's our converse. Okay. If you prove the converse of corresponding angles, okay, then you can basically prove the rest. You can prove the rest. Okay, because those only work if the converse is true. Moving on. Scroll down or look in your book. We have a bunch of definitions. The converse, remember the converse is if Q, then P. Excuse me. Parallel lines. Parallel lines, they never intersect. And those will never intersect. Ever, ever, ever. They go on forever, they never intersect. The transversal is, let's say we have two lines. They don't have to be parallel. We have two lines, okay, and this red line I'm drawing, that's our transversal. Okay, the line cutting through two lines is our transversal. Okay, corresponding angles. Corresponding angles, let's say we have two lines here. Actually, corresponding angles, I'll say over here 1 and 2, okay? Because in this drawing, corresponding angles 1 and 2, okay? They're both on the left side of their line and above the their respective lines. And those aren't congruent corresponding angles because they're not parallel, but they are corresponding. Okay, congruent. Congruent means they are the same size and shape. Okay, alternate interior angles. Here I'll do an example with parallel lines. Let's say we have two parallel lines. and they're parallel. We have this little tick mark here that says they're parallel. They'll never intersect. Then we have our transversal in red. Okay. Corresponding angles, or alternate interior angles. I'll say 2 and 3. Okay. Alternate interior. So they have to be inside their two lines. So 2, and they have to be alternate the transversal. And opposite sides of the transversal. Alternate exterior angles, we'll say 4 and 5. Okay. They have to be on the opposite sides of the transversal, so one has to be on top, one has to be on the bottom. And they have to be on the outside of their respective lines. So we'll say 4 and 5. Those are alternate exterior angles. Okay. And then we'll say 1 and 3 are consecutive interior. Right, they're both on the bottom of that transversal, and they're both on the inside of their respective lines. Moving down, we have a couple theorems, right? Corresponding angles. If two lines are cut by transversal, so the corresponding angles are congruent, then the lines are parallel, right? Corresponding angles. That's the converse. Okay, so theorem 3.5 is the converse, proving that they're parallel. Come on now, move with me. There we go. Another converse, right? If the alternate interior angles are congruent, then the two lines are parallel. Alternate exterior, same thing, except with exterior. Consecutive interior, those angles are supplementary if and only if JK are parallel. Transitive property of parallel lines. If two lines are parallel to the same line, well then they're parallel to each other, right? If P is parallel to Q and Q is parallel to R, then P is parallel to R. Moving on here to some example problems. In exercises 1 and 2, find the value of x that makes m parallel to n. Okay, explain your reasoning. Okay, well these are corresponding angles. Okay, they're in the same spot. They're both below their respective line, and they're on the right side of the transversal. So they're corresponding. And for these lines to be parallel, m and n, they have to equal each other. These two angles have to equal each other. So 95 has to equal 8x plus 55. Okay? Solving this, we get 8x is equal to 40. And then x is equal to 5. Okay? Explain your reasoning. We can say corresponding angles equal each other only if m is parallel to n. So those only equal each other if those two angles or two lines are parallel. Number 2. These are alternate exterior angles, right? They're on the outside of their lines, M and N, and they're on the opposite sides of the transversal, okay? And these will only equal each other if M and N are parallel. So we set them equal to each other. Okay, and then we solve. Okay, and I kind of went through that a little quickly. Again, alternate interior angles, okay, I'm going to abbreviate, alternate interior angles only are congruent when m is parallel to n. Okay, these are only congruent if m is parallel to n. Sorry, this is not alternate interior, it's alternate exterior angles. And they're not interior, they're exterior. Moving down, number 3, decide whether there's enough information to prove that M is parallel to M. So all we have to think of is there enough proof? Okay? Here, it says that this angle is congruent to this angle. Those are corresponding angles, okay? And they're congruent. Well, yeah, that means that M has to be parallel to N. So we're going to say that this is true, or there's enough proof there. Good. Number 4, is there enough information to say that M is parallel to N? We know that this angle and this angle is congruent. Okay, those are vertical angles. That should always be true. But I'm going to draw some over here. If I had something like this, right, and this was M, and I had something like this, and this was N, then I have my transversal, okay? These two angles are still equal to each other. Okay, so this is actually going to be false. There is not enough information there to prove that M is parallel to M. Moving down. Oh, I can't move down anymore. Number 5. Is N parallel to N? Okay, where's M and N? M is right here, N is right here. Okay. Again, those are just vertical angles. There is not enough proof here to prove that M is parallel to N, so this is going to be false. And this last one, look at M and N. Where is M? M is here, and N is here. These two angles are congruent right here. Doop, doop. Those are alternate exterior angles, and those are only congruent when those are parallel. So this is true. There is enough information. Okay, they're only congruent if those two lines are parallel.